Hello everyone, welcome back to Let's Crack JEE in English, the channel of Unacademy, and I'm Jeetendra Dixit. So before we begin, just let me check my voice. All right. Okay, so let me introduce myself. I'm Jeetendra Dixit. I did my BTech from IIT Kanpur, and I have been mentoring IIT-JEE aspirants for the last 11 years. So I teach mathematics, and we were doing a straight line, and this is the first session of pair of straight lines. Okay, so we have already finished the straight lines. Now we'll start pair of straight lines today. So now, before that, let me also introduce you with the Unacademy's platform. As you know, Unacademy is India's largest online learning platform, and if you are preparing for IIT-JEE, then you can buy two types of subscriptions on Unacademy. One is Plus subscription, and other is Iconic subscription. So if you buy Plus subscription, then you get access to daily live classes of all the educators who are teaching for IIT-JEE. You get their live sessions as well as recorded sessions also. You can watch the recorded sessions. I mean, if you miss something, you can watch recorded sessions by downloading them also offline, I mean. And all the live tests and quizzes will also be accessible. And the courses which I was talking about of the top educators of India who are teaching on Unacademy are well structured. That means you can just see the schedule of all the complete course in well advance. You can see all the upcoming lectures planning with time, date, and schedule. So accordingly, you can plan your sessions. This is unlimited access which you are getting on by buying this Plus subscription. These are the subscription charges. You can subscribe for 1 month, 3 months, 6 months, 12, and 24 months. 1 month is it is 7,000. 3 months it is 17,500, and so on. But if you compare it with 12 and 24 months packages, you can see that these two will have the least per month average package. Hello Gia. Now the second is Iconic subscription. So in Iconic subscription you get a personal coach, who will guide you throughout your preparation for IIT-JEE, and all the benefits of Plus are also accessible to you. So apart from that, you are getting this personal coach, and all your test analysis will be done in a personalized manner. Personalized feedback will be given to you. Improving your time management, to improve your time management and exam approach, and your study plan will also be customized. So these are the additional benefits in Iconic subscription. You can subscribe for 6, 12, and 24 months. And yes, you can use JEET1, this code, get instant 10% discount. Now this is Unacademy's learning app which you can download from Play Store, and after downloading it, you can start attending free content. You can see a lot of special classes you can watch for live and free without taking any subscription. But you will have to use the code, referral code, to enter the free access of free content also. So you can use the same code JEET1 to access that. Now let's begin pair of straight lines. Yeah. So pair of straight lines, when you multiply, suppose two equations of lines are given. This is ax plus a1x plus b1y plus c1 is equal to 0, and this is another line which is a2x plus b2y plus c2 is equal to 0. So if you multiply these two equations, as I was okay, I told you in previous session also, I think, if I multiply these two equations, then the new equation represents the combined equation of these two lines, a1x plus b1y plus c1 into a2x plus, a2x plus b2y plus c2 is equal to 0. So you have multiplied these two equations, L1 and L2, all right? This is, if this line is say L1 and this line is say L2, then this is L1 into L2 is equal to 0, and it represents the combined equation of both the lines. That means pair of lines, all right? So you can expand it, and after expanding it, you can see the terms will be like this. Some a into x square plus b into xy plus c into x square. I'm writing in general, plus d into x plus e into y plus f is equal to 0, something like this. Okay, so it will be a 2-degree equation, like one line equation of one line is linear in x and y, but combined equation of two lines will be 2-degree. So 2-degree means 2-degree general equation. 2-degree general equation means it has 2-degree terms. These are 2-degree terms, and linear terms, these two are linear terms, and a constant term, 0-degree term. So 2-degree general equation, like quadratic, in quadratic polynomial, you say 2-degree quadratic polynomial. That means it has 2-degree term, it has linear term, it has a constant term as well, right? Similarly here also I am calling this 2-degree general equation. That means it has 2-degree terms, it has linear term, it has constant term also. But before we go to this general equation, we are going to discuss homogeneous equation. So what is homogeneous equation? Let me tell you that. All right. So homogeneous equation of nth degree polynomial in x and y is like this: an x raised to n plus an minus 1 x raised to n minus 1 y plus an minus 2 x raised to n minus 2 y square, and so on up to a naught y raised to n is equal to 0. So if in any equation all the terms are of same degree, if all the terms are of same degree, then that equation is called homogeneous equation. Like in this equation, you can see all the terms of x and y, of course, so are of nth degree. This is the nth power of x, and this also you can see this is nth power of x and y. You can combine these powers and just add these powers of x and y, and you can see this is nth degree term. Similarly, in this also, this is nth degree term. Sum of powers of x and y is n, and this is also nth degree term, right? So now you can see these are all these terms are of nth degree. So this is nth degree homogeneous equation. All right. So you got this homogeneous equation. If all terms are of same degree, then it is called homogeneous equation. Like if I like homogeneous equation in 1 degree, then it is like this: ax plus by is equal to 0. So both terms are of 1 degree. This is homogeneous equation of 1 degree. If I write this equation, ax square plus by square plus cxy is equal to 0. This is homogeneous equation of 2nd degree. All right. Similarly, you can write homogeneous equation of 3rd degree and so on, right? So I think you have got it. All right. Okay. Now let me tell you one very important point. So this is the important point. Homogeneous equation of nth degree always represents straight lines passing through origin. Okay, so nth degree homogeneous equation will represent n straight lines, and nth degree homogeneous equation will represent n straight lines. All right. If you have 2 degree homogeneous equation, it will represent 2 straight lines passing through origin. If you have 1 degree, like this you can see this is 1 degree homogeneous equation. So this is a line passing through origin. Line passing through origin is of this type: y is equal to mx. All right. or in fact you can write slope is equal to y upon x. So line which passes through origin is of this type, y is equal to mx. So nth degree homogeneous equation always represents n straight lines passing through origin. Now these straight lines might be of real slope or imaginary slope. Slopes might be imaginary also. That means if line is of imaginary slope, then it won't be real. No real point will satisfy that point except 0, 0. All right. 0, 0 of course will satisfy, because even if you write y is equal to mx and m is not real, like imaginary number, then also 0, comma 0 will satisfy this equation. But other than 0, 0, no other point will satisfy it. Okay. So we call it a straight line of imaginary slope, but we still call it a straight line. All right. Even if m is not real, then also we call it a straight line, okay, of imaginary slopes, but it is called a straight line. All right. That's why we are saying that this will always represent a straight line. See, as I was telling you that y is equal to mx represents a straight line passing through origin. So m can be written as y upon x, or y upon x can be written as slope. So in this equation, now see how to show it that it represents n straight lines. Divide this equation by x raised to n. Divide by x raised to n. If you divide by x raised to n, it is going to be a naught y upon x raised to n plus a1 y upon x raised to n minus 1 plus so on up to an. This is equal to 0. Now you know y upon x can be written as slope. So if I write y upon x is equal to m or t, whatever you want to take. So let's take y upon x is equal to m. I am taking m. Okay. So a naught m raised to n plus a1 m raised to n minus 1 and so on. Then it will be an minus 1 m plus an is equal to 0. Now clearly you can see it's a polynomial in m of degree n, right? This is a polynomial of degree n and polynomial in m. All right. So any polynomial has n roots, right? And any polynomial of degree n has n roots. So this equation, a naught m raised to n plus a1 m raised to n minus 1 and so on up to n minus 1 into m plus an is equal to 0. This polynomial in m will have n roots. Okay. So let's take the roots as m1, m2, m3, right? Real or imaginary, but it will have m roots, n roots, I'm sorry. Okay, n roots. So these are the roots. And you know what was the value of m? We put m is equal to y upon x was m, right? Y upon x. So these are the values of basically y upon x. So y upon x, you will get m1, y upon x is equal to m2, then y upon x is equal to m3 and so on, right? Y upon x is equal to mn. Now what are these equations actually? So this is y is equal to m1x, first line. This is y is equal to m2x, second line, right? And all these lines are passing through origin, all right? Yeah, slopes might be real or imaginary. I'm not saying that all slopes are real. Slopes might be imaginary or as well. Is that okay? So you got this general concept. This was the general concept. Now we need to discuss 2-degree homogeneous equations. So now let's come back to 2-degree homogeneous equation. So it's very similar to quadratic 2-degree homogeneous equation. Now all the points which we are going to learn in this 2-degree homogeneous equation are very similar to the quadratic chapter. Okay. Hi Shubham. Very similar to quadratic chapter. Now 2-degree homogeneous equation is written as ax square, general equation ax square plus 2hxy, we take coefficient of xy is equal to 2h, plus by square is equal to 0. 2h because h is frequently used in most of the relations. In most of the relations, h is used. So that's why we take coefficient of xy as 2h. If we'll take h, then it will become h by 2 in all the relations which we are going to prove. So to write those relations nicely, we have taken coefficient of xy as 2h. Okay? Simple. Now this is a equation. Now we need to separate the lines represent. So this represents two lines passing through origin. All right. So let's make a quadratic in y upon x. So divide by x square. Divide by x square to separate the lines. Then you can write b into y upon x the whole square plus 2h into y upon x plus a is equal to 0. Now y upon x is basically m. Let's take m again. And then it is b m square plus 2hm plus a is equal to 0. Alright. Getting it? Now you can see this will represent, so you can solve this quadratic and find roots. So let's say roots are m1 and m2, then lines represented by this one equation, lines represented by 1 are y is equal to m1x and y is equal to m2x. So we'll get the lines easily, okay? In this way, you can get the lines. So basically it's like solving a quadratic equation. All right, understood? Now here we can also find the conditions for real lines of real slope, lines of imaginary slopes, or maybe coincident lines, because all the lines are passing through origin. So if slopes becomes if both the slopes are equal, then lines will become coincident because y is equal to mx and y is equal to mx. So both lines are passing through origin and of same slope. So that means they will be coincident lines. Say this is y is equal to m1 line, m1x. And this y is equal to m2x. Alright. Now if m1 is equal to m2, then how would this diagram look like? Both lines will be like coincident lines. This is the case when m1 is equal to m2. So both lines will be coincident now. So this will be the line y is equal to m1x, and same line is y is equal to m2x also if m1 is equal to m2. Right? Coincide. Yes, they will coincide. Okay. So let's find the condition. If I write the discriminant of this quadratic, then discriminant is 2h the whole square minus 4ab. We know the condition of real roots of a quadratic. So you can write this discriminant is 4 times of h square minus ab. So sign of this, now you can see this is what I was saying, that we take 2h so that we get expressions like this. This is now the main thing on which sign of discriminant is dependent. So D is positive. So D is positive. D is positive means h square is greater than AB, right? This implies that lines represented by 1 are real and distinct, real and of distinct slope. So slopes are real and distinct. This is the first case. Second case is when discriminant is equal to 0. This means h square is equal to ab. In this case, slopes will be equal. That means it will represent the case of coincident lines. Okay, this is the first case, this is the second case. All right, coincident lines. Now the third case is when discriminant is less than 0. This means h square is less than ab, and this means lines represented by 1 will be of imaginary slopes, but we will call them lines only. Lines of imaginary slopes and passing through origin, but they both will pass through origin. Okay, so this is the way to say it. Because 0, 0 will anyway satisfy y is equal to mx, whether m is real or imaginary. So lines will pass through 0, 0, but imaginary slopes, direction is not defined. So no other real point will satisfy that equation y is equal to mx. Is that okay? Got it? No, actually, in complex plane we take more general equation actually, not this. In that case, when we write the equation, then in that we write the equation in z actually there, and slope is also defined separately, not this type of slope. The slope is defined. That slope is called complex slope. So this is another way of representing it, not this particular line. We'll have to define complex slope, so that you will study in complex numbers. Just a moment. Anything else? All right. Now suppose you have two pairs. Now we got the conditions when is lines real and imaginary. Now similarly, like in quadratic, we did condition for one root common. So similarly, now suppose you have two pairs, a1 x square plus 2h1 xy plus b1 y square is equal to 0. And second pair is a2 x square plus 2h2 xy plus b2 y square is equal to 0. If these two pairs have both lines in common, then the condition is a1 upon a2 is equal to h1 upon h2 is equal to b1 upon b2. How did we get this condition? Because both lines are common, that means these two equations of slopes, okay, b1 m square plus 2h1 m plus a1 is equal to 0, and b2 m square plus 2h2 m plus a2 is equal to 0 will have both slopes common. These two equations have both roots in common, right? So if both roots are common, that means condition is b1 upon b2 is equal to 2h1 upon 2h2 is equal to a1 upon a2. That was the condition in quadratic. If both roots are common, then a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. Are you getting this? Similarly, there is 1 and there is 2. Similarly, if 1 and 2 have one line in common, then apply the condition. Apply the condition of one common root in these two equations, equation number 3 and equation number 4, right? In 3 and 4. And you know what was that condition? We used to write this Cramer's rule, m square upon 2h1 a2 minus 2h2 a1 is equal to m upon we used to write minus a1 b2 minus b2 a1 b1 a2 is equal to 1 upon b1 2h2 minus 2h1 b2. Then eliminate m or you'll get the condition. So this was the, like we did in one common root case in quadratic, the similar thing. Are you able to relate it? Okay. Then one more formula. Angle between the lines. Angle between the lines represented by ax square plus 2hxy plus by square is equal to 0. Alright. So basically we know that lines represented by are, if lines are y is equal to m1x and y is equal to m2x, where m1 and m2 are, where m1 and m2 are the roots of, किस equation के roots हैं? bm square plus 2hm plus a is equal to 0, roots of this equation, right? So m1 and m2 are the roots of this equation. So we can write these two relations. Sum of the roots m1 plus m2 is equal to minus 2h upon b, and m1 m2, product of the roots, which is a upon b. These two are very important relations which we need to prove many formulae like angle between the lines. So angle between the lines can be written as if let's say let angle between the lines is theta. This is 0, 0. This is y is equal to m1x. This is y is equal to m2x. This angle is theta, alright. The tan theta is equal to m1 minus m2 upon 1 plus m1 m2 mod. Alright. And then m1 minus m2 is under root of m1 plus m2 the whole square minus 4m1 m2 divided by 1 plus m1 m2. Okay, and now we can put these values m1 plus m2 and m1 m2 and we'll get the formula. So it is going to be 2h the whole square upon b square. So if I take LCM, it is going to be minus 4ab divided by b will come out because b square will be the LCM, and is 1 plus a upon b. Now you can multiply it by b, so it is going to be under root of 2 times of under root of h square minus ab divided by in denominator it is going to be a plus b. Alright, a plus b. You can put mod for acute angle. Okay, are you getting it? This is the formula. Okay, so we can remember this formula in terms of h, a and b. So we need to memorize this formula: 2 under root of h square minus ab upon a plus b. 2 under root of h square minus ab upon a plus b. We need to memorize this formula because when they are asking for the angle between the lines represented by these two equations, then we are not going to separate the lines first of all. Okay, we are not going to find the slopes and then we'll apply m1 minus m2 upon 1 plus m1 m2. That might take more time. because m1 m2 might be rational also. Then finding m1 m2, then putting in that formula m1 minus m2, it's better to use the values of a, b and h directly. So memorize this formula. This is angle between the lines represented by these two equations, and from this now we can say that this tan theta is 2 under root of h square minus ab upon a plus b, and mod also because of the acute angle. So if h square is equal to ab, then lines will be, tell me what was the condition? We have also done it, right? Theta will be 0. Theta is equal to 0 in this case, and lines will be coincident, right? We have already done it, right? We got the same. No, not x-axis. Lines will be coincident. Angle between both the lines will be 0. This is not the angle between x-axis. This angle between both the lines. This theta is this. Oh, in previous diagram you took it. This was not x-axis. X-axis is like this. This is x-axis and this is y-axis. Got it, now? Lines will be coincident. Okay. We already got this condition earlier also. See this one. We got this condition h square is equal to ab here also by putting the discriminant is equal to 0. And we are getting the same condition here also because h square minus ab is a part of discriminant and it is also in this formula. Right? And the second for perpendicular lines. Now this is a second is if a plus b is equal to 0. See, if this denominator becomes 0, then theta will not be defined. That means theta is equal to 90 degree. That means lines will be mutually perpendicular. Lines will be mutually perpendicular. That means lines of this type, ax square plus 2hxy minus ax minus ay square, alright. So you can see coefficient of x square and coefficient of y square are of equal magnitude but opposite in signs. That means lines represented by the equation are mutually perpendicular. And of course it will be real, no need to check. Because if a plus b is 0, that means h square minus ab will certainly be positive. Are you understanding it? Like this, 2x square minus plus 4 minus 4xy minus 2x square is equal to 0. Now you can see these two, sum of these two is equal to 0. So this will represent two perpendicular lines, and lines will certainly be real because they are perpendicular, that means real. If a and b are of opposite signs, that means discriminant is positive. H square minus ab is positive. Alright. All right. Okay. Now let me give you some questions. Let's do some questions based on homogeneous. And this part of 2 degree, two parts are very important in pair of straight lines. One is this homogeneous equation, homogeneous part. So homogeneous equation is very important in all the exams. They generally ask questions in like JEE main and state level exams or like bits based on this homogeneous equation because it is very similar to quadratic, very similar to quadratics. You can relate quadratic with this pair of straight lines and everything will be like quadratic equations. Okay, so main point is relating this theory of this homogeneous equation with quadratic. And after that, we are going to learn the general equation also. The general equation will also have the formulae in which will use the importance of this homogeneous equation, whatever we are doing here, like angle and all, discriminant, everything will be used in general equation also. So find the, okay, my first question is find the centroid. Find the centroid of triangle the equation of whose sides are 12x square minus 20xy plus 7y square is equal to 0 and 2x minus 3y plus 4 is equal to 0. Are you getting it? All right, solve it. Yeah, right. 8 by 3, 8 by 3 is the right answer. So you just need to separate these lines. Wait a minute. We just need to separate. So what are the lines you are getting? You can make a quadratic. So 7m square minus 20m plus 12 by dividing x square, dividing it this equation by x square, and then you can 12 into 7 and 20. How do you split it? 14 and 6. Now there is 7m common, then m minus 2, and minus 6 common, m minus 2. So it is m is equal to, you will get one value as 2, another value as 7 by 6, 6 by 7. Right? Now this is y is equal to 2x, this is one equation, and this is y is equal to 6 upon 7x, this is another equation, okay? Right, and then you can solve it with these lines. So solve these lines. So one point is of course 0 0, solve point of intersection of these two lines. And if you solve, what are the points you are getting here? If I put y is equal to 2x in this, then it is going to be, solve this line number 1, line number 2, and line number 3. So if I put line number 2 in this, it is going to be y is equal to 2x. So it is going to be 2x minus 3 into 2x plus 4 is equal to 0. All right. So it is going to be 2x minus 6x plus 4 is equal to 0. So this is minus 4x plus 4 is equal to 0 and x is equal to 1. So it is 1 comma 2, right? The second point is 1 comma 2. And similarly you can solve 7 comma 6. The third point is 7 comma 6. So now you can write the centroid. These are the vertices. All right. So what points are 8 by 3 comma 8 by 3. Okay, good. Now the second question. If the pairs of lines x square plus 2xy plus ay square is equal to 0 and ax square plus 2xy plus y square is equal to 0 have exactly one lines in common. Exactly one line in common. Then find A and also the combined equation of remaining two lines. Try this one. Are you getting any value? It's like this. if you make a quadratic in m, then the first equation is going to be am square plus 2m plus 1 is equal to 0. And the second equation is going to be m square plus 2m plus a is equal to 0. Jia, have you got any value? See how to solve. How do you solve these two equations to find a? These two equations have one root in common. I hope you understood what have I done. Now we have divided by x square in first equation and second equation to get these two equations of slopes, quadratics m in m. Now to find, we cancel m. We do not apply that formula Cramer's rule which we are applying to prove that result basically. So we are not going to memorize that result. We are not going to apply that particular formula or in fact the derivation. We simply find m, okay, by solving these two equations. We put that value of m in the given equation only. So you can see if I solve them, simply subtract, you'll get m. So if you subtract, this will get cancelled. It is a minus 1 into m square plus 1 minus a is equal to 0. Alright. So you'll get a minus 1 into m square minus 1 is equal to 0. I'm getting m is equal to plus minus 1 simply. So m is equal to, you'll get m square is equal to 1 and m is equal to plus minus of 1. See, it was so simple. M was plus minus 1. Now you can put the value of m in this equation. So put m is equal to 1. M can be 1 or m can be minus 1. Okay. So put m is equal to 1. Then you get one value of a. So what we do, I'm repeating, whenever you have two quadratics and it is given that exactly one root is common, and find the value of parameter, whatever parameter they involve in their equation, then what you do, first you solve these two equations and find the value of the variable x if quadratics are written in x. Then find x, okay, by solving them simply. Okay, you can find x square or you can find x, whatever you want to. Like in this case, I just cancelled 2m and I got m square easily. So I got two values of m, plus minus of 1. Now after getting the value of variable, just put the value of that variable in the given equation, any one of the given quadratic. So now we have got numerical values of m, so we can put it easily. So m is equal to 1. If I put m is equal to 1, it is a plus 2 plus 1 is equal to 0. That means a is equal to minus 3. Or if I put m is equal to minus 1, then I'll get a minus 2 plus 1 is equal to 0. That means a is equal to 1, right? But if I take a is equal to 1, then you clearly can see that these quadratics will have both roots in common. If I take if a is equal to 1, just rechecking. If I put a is equal to 1, then I can see these quadratics will become identical. See this m square plus 2m plus 1. And these quadratics will become identical means they will have both roots in common. So that means one will be rejected. This will be rejected because it was given that they have exactly one root. Exactly. So m is equal to minus 3 is the right answer. A is equal to minus 3. Are you understanding it? Have you got it? Now you can find, now putting a is equal to minus 3, you can find the roots of remaining two quadratics. I mean, what are the remaining roots? If I put a is equal to minus 3, if I put a is equal to minus 3, then the first equation is going to be, m square, 3m square, minus 2m minus 1 is equal to 0. So obviously, of course, one root is, what was the one root? M is equal to 1. M is equal to 1 was the one root, so other root is going to be, product of the roots is minus 1 by 3. So the other root is going to be m is equal to minus 1 by 3. These are the roots. Got it? This is the other root. Now similarly, we can find the second equation also. So that is m square minus plus 2a minus 3 is equal to 0. Just putting a is equal to minus 3 in these two equations. Equation number 1, equation number 3 and equation number 4. Okay. So now putting the value of a, I have got this quadratic, and again one of the root is 1. So other root is going to be, use product of the roots, because you know one of the root is 1. So using product of the roots, you can write the other root easily. So one root is 1 and product of the roots is going to be minus 3. So other root is m is equal to minus 3. Okay. So these are the values of remaining two lines, slopes of remaining two lines. So if you need to write the combined equation, then the combined equation is going to be y is equal to mx, or y minus mx, so y plus 3x. This is first line, this one, and if I write this line, this is going to be 3x plus y is equal to 0. Now expand it, so you can write the in quadratic form. It is going to be 9x square plus 3 plus 3, 6xy plus y square is equal to 0. All right. Got it? Got it, Jia? So today we have doubt clear. Tomorrow is the practice session for straight lines. Today is doubt clearing session. Tomorrow is again practice session for a straight line. Okay. So tomorrow we'll practice questions, and tomorrow we'll continue in this session. We'll continue on this theory of pair of straight lines. You can start your pair of straight lines. So remaining things of related to this 2-degree homogeneous equation, and then we'll also go to general equation. Okay. After that, it will take 3-4 sessions. And last portion, homogenization, is also very important. Homogenization. All right, Jim. Okay then. Take care.